All right. Sorry. Oh. Let's run web. Oh, no, not that. Just watch. There we go. That's the right Rust config flags. This should go pretty quick because it's already built. And then I didn't do anything yesterday. So we are, in general, at the same part that we were. I seem to have created a panic. So let's debug that pretty quickly. DevTools, unreachable. Yes. Somebody else filed an issue on Scheme, so I used this as a test project to reproduce the error, and that is in playing. Basically, this is what it was. So if you spawn trimesh from mesh from a from a collider constructor, Avian will panic. Hey, how's it going, Anders? Man. I'm gonna have to move. So this now doesn't panic. Like I said, when I started the stream, we have nothing beyond what we did on Saturday. Sunday for me is a This Week in Bevy day. And I have a particularly large backlog over the last couple weeks. So I spent it all on This Week in Bevy instead of the game. So today we need to kind of like get into this controller and do what we can to make the controller actually like interact with the landscape. I think there's like roughly two ways we can try to do this. One is we can make it dynamic. And then if we make it dynamic, we have to do a bunch of other physical things. And that's the character controller dynamic. If we make it dynamic, that's better for a game jam to start out, because the dynamic rigid body interacts with the world in certain ways. But as you will be able to see, it comes with certain drawbacks as well. For example, that's the behavior with the dynamic rigid body. So, like, to some extent, we could use dynamic. If we needed something that was more complicated, Bevy Tenua does have a 0.16 release. I don't really want to use Tenua for this. You know, it is what it is. Basically, the mechanics that we're going to need to implement here are the player will be able to... Damn. The player will be able to basically like go off the ledges that we see here. And if they land correctly, we'll say, if they land with the tangent like perpendicular to the velocity, basically, if we do a dot product and they're similar enough, then you get like a perfect landing, and we should be able to not just take like the tangent of the collision and make that the new linear velocity, but also maintain the magnitude based on how good the landing is. So if the vectors are similar enough, then you have like a perfect landing, so to speak. And you should be able to maintain more of that velocity. And in some cases, probably boost over that velocity based on the perfect landing. Which is all stuff that I think we can do with kinematic or dynamic. I think if I was going to make this and I had a little bit more time to do it, I would definitely go kinematic. Because this feels just like Collide and Slidey, which is part of the reason that this game in particular was attractive as a game jam game. If we do dynamic, then we need to like get rid of all friction to start with. So one of the things we can do if we're going to do that is set the defaults. We've got physics plugins here, right? So if we do insert resource, default friction 0, and insert resource, well, I don't think we need to adjust the restitution right now. We'll see in a second. So default friction, apparently that's not how we do default friction. What is default friction? Avian 3D. Default friction has to be a friction. Oh, friction new is what we need to do. Friction new 0. So no friction, and no friction on anything. So the combine rules shouldn't matter because there's no friction anywhere. This isn't really enough because our velocity will degrade over time if we don't maintain it. But you can see immediately how it's a little bit more, like it goes a little further, right? And it slides a little bit, and that's fine. That's not really what we want, but in the grand scheme of things, this slide is going to be counteracted by either player behavior or velocity pushing forward. So I wouldn't be too worried about it. This gives us like very easy collision with the landscape, right? Like obviously the collision with the landscape is working because we can see it working. And you can see that like when you land on certain areas, it bounces off to a certain way. I don't really want like perfectly physical collisions. Like the point of this is not necessarily to like hit a wall and bounce off correctly. Because the whole goal is to just go straight, right? The whole goal is to just like keep going down this like course or whatever and try to hit more landings, try to chain more landings together, try to chain those together with like rings or something like that. So we could make this basically a collide and slide, but like only basically just take the like the dot of the velocity and the tangent and just take or add magnitude from that vector. And I think that would be enough. So the problem with dynamic, or not the problem with dynamic, the problem with kinematic, especially for a game jam, is that we actually have to code everything. which obviously can take a while. So if we can reduce the amount that we have to actually write, then this becomes more reasonable. And then it just like right now it's just taking the linear velocity and like it isn't like affected by the landscape at all. So we have to implement like collision with the landscape and how we want that to occur. Which means we need to make decisions and we need to do actual collision and whatnot. I think that we still have a colliding observer here, but the collision observer is not necessarily what we're going to want, I don't think. So if I open the dev tools and we clear this and we open, then this collides here, should collide there, but I guess it was still colliding, so it wasn't restarting. Like this is all one, oh, there's 9 collisions, 10 collisions, 11 collisions. So there's a bunch of collisions. We could start off with that and kind of react to those. Right? We kind of have to implement gravity, right? I guess gravity really only applies, well, not only applies when you're in the air because you need to kind of like, I guess you don't really need to stick to the ground. Like we don't really need gravity because the player is going to have the ability to fall fast, right? And that can basically replace gravity while you're running. So we don't really need gravity per se. This velocity, oh, this should have been persistent on that dynamic controller. Why wasn't this force persistent? Yeah, I do want to know that. External force, persistent bool, external force new. Persistent should be the default. So spawning a rigid body with a force should work. So why didn't it? Because I feel like it should be continuous here. And it's just not. Where's the force? Let's make this something like ridiculously obvious, like 100. I looked at my stream while the page wasn't refreshing. And I was like, oh no, the stream isn't showing. But no, it's just the page refresh. So like this just stops. What's going on here? Where's our player? Our player is unnamed. Did I not name the player entity? I guess not. I guess I didn't name it. Let's do name new player. So that shows up in Bevy Inspector eGUI as the like player label. So we start, we look for player, that's player here. Wish I could make this bigger, easier. Where's our force? Our force is here. Persistent force. Did I put that on Y? That's why. Interesting. Right, so this kind of like by default does what we want it to do, except for the fact that like bouncing off whatchamacallit. Let's see. Vec3Y. Why did I do Vec3Y? It's Vec3Z. 100 is going to be too much now. So let's just like start with 30 or something. I need to like make tea before I stream these days. Oh, right. Also, what I meant to do was do this scene. Because we're doing the jam. Okay, so this goes, and it's like, it's fine per se, but like that bounce is really weird, right? And that force is constant. And the force isn't really what we want. We basically want something like if player holding well, no. We want that impact that like bounced the character to like reduce the velocity quite a bit, because like this is right, like that bounce was just, it's just weird for the gameplay. So like external force is like constantly accelerating. We don't really want that. We want to set the velocity. So like, is there a minimum velocity in Avian? I don't even remember. Or do we have to maintain that ourselves? Velocity damping, that's not what we want. Angular velocity, external force, linear damping, max linear speed. Max linear speed isn't what we want. We want like a min linear speed, but I guess we can be the min linear speed we want to see in the world. So delta seconds, linear velocity time, linear velocity. Guess we'd really want to do magnitude. We can kind of stick this in the Z position. Sorry, I had to touch the HDMI cable. No HDMI signal. Did I mess up? HDMI input. There we go. If we do minimum velocity, and we set this to like some value, hard code, then that's fine for the moment. But yeah, I think there's a lot to think through there. Maybe we just do that for now. Linear velocity. I guess we just set it in the X direction for now. Or the Z direction, sorry. This isn't really what we want. We kind of want going... We want it going in the direction of the last user input. We don't have any user input yet. So now we have like Z velocity, but like we're kind of bouncing around left and right. We're kind of bouncing off the landscape, and like this bouncing isn't what I want. But I think we only get yeah, I need to check something. The bouncing is not what we want, right? So we can implement Bevy enhanced input to do some minor control here, left, right. But if we did dynamic, how would we get rid of the bouncing? And I don't really have an answer for that. Like we could go with something like Tenua. Tenua is quite a bit. We kind of want let's see, we get to desired velocity, float height, etc. This is like walking up slopes and stuff. We have plenty of slopes. Like you should be able to basically walk up any slope, I feel like. We're not going to have a jump. We're not going to have a crouch. We're not going to have dashing yet. So really the only thing we would get out of this is the floating part of it. Yeah. I feel like I want to do the kinematic version of this. I feel like getting the physical response to be what I want is not going to be particularly easy. So the question is, what would the difference be? The kinematic controller could use like shape casting. So I'm just rerunning this because it keeps running off the side because of the directional. I guess we could do input next. Input would be fine because input is regardless. Like we need input anyway. So that's good progress to make anyway. Bevy enhanced input is what we're using. They have some examples. Their examples should include... I guess this isn't really... They've got their bindings and stuff. This is really what I want. Modifier, smoothest nudge default, make movement smooth and independent of frame rate. Christ. We aren't gonna do mouse stuff, so let's do Bevy enhanced input. I know they have a little like tutorial section up here, so might as well just start here because I don't think we have the plugin installed yet. So let's go to main. I'll throw in the enhanced plugin. We should have to pull in the prelude, where we're going to use this. The controls, I guess we can throw controls in the same playing plugin over here. I don't feel like there's a lot of value in separating things at the moment, so we'll just throw it in here. We need movement. Well, this might be the value, right? The value would be movement, use Bevy prelude star. Throw this in here, use Bevy enhanced input. Movement plugin, input plugin. This will be pub. We don't have any configuration here, so this is basically just going to be the thing we pull in and use in main. So movement has some stuff. Input context, yada yada. This is bound stuff. We don't really need all of this. We need the observer. And this is the code we need to put in the observer. We don't really need like A and D. We need W and D. But it's fine. We can just ignore Y for now. And then it wants us to set up the observer for binding actions to our input. So we'll do that, right? And then this observer will be this function signature. And we'll take this and we'll move this up. We don't have a jump, so we don't need it to be that. We don't have app settings currently, so we just won't do that. We don't have a, kind of unfortunate that this doesn't have the full code in the little tutorial here. They have a input context, so on foot. So theoretically we could have like an input context for on foot and an input context for like in air or something. I think on foot is fine, or grounded maybe would be the right way to frame that. Sorry, my neighbors are still smoking and it's really still bugging me, so trying to just go through it. Movement plugin. Grounded, we have WASD. We should be able to get these actions in another system. Let's just grab the function signature for that. That should be not this binding, but this trigger move. So we end up with add observer, apply movement. We get the movement. In this case, we're getting the transform. I guess we don't really want transform for our sake. We want linear velocity. And then the trigger value is a vec2. So trigger.value. And what do we actually want to happen to the linear velocity? We want to rotate the direction of the current velocity we have, I think. I don't think we want to add any velocity. So it's really more like if we had a circle and an arrow pointing off, we would want to rotate the arrow a little bit in a direction rather than having a forward input. I guess having a forward input could theoretically be useful for restarting, but I think we'll never let them stop. Maybe, I don't know. Stopping might be a different input context. So like if you're not moving forward, then you are in the like not running input context or something, in which case we would start using that forward component. But I think that the forward component here is only useful in the sense of the direction. And we're only really going forward, and I think I'm going to have a fixed camera in the sense of like it's going to be up and behind the character. So I think that the input then could be directly translated to an angle. And then I think we can do magnitude of the current velocity times the angle. So linear velocity with player. For mute linvel in and mute players. This is not pub from our playing. Movement linvel. So if we have trigger.value dot to angle, I think it gives us radians times linvel dot length. And this is our new velocity. No. Let's see, radians dot to, I guess we just need to normalize this, right? And then we multiply that by length, and that's our actual input. Theoretically, this makes keyboard input pretty hard, because keyboard input then wouldn't be a rotation per se. This is like very much controller input. I don't know how much that matters for the game jam. Bevy uses so much CPU. I don't know what you mean by that. Are you one of the people that ran an empty project and were like, look at my CPU? Okay, so we don't have all that much going on here. I don't think that we end up with anything going on there. Let's do linvel equals newvel. I think this is going to be weird because specifically, okay, this is a vec2. Linear velocity is not a vec2. Linear velocity dot zero should be a vec3. And then this is going to be Dang. Um, I think really what we want to do is apply this movement to the X and Z components individually, and not the Y. And the Y should stay what it is, but that math seems more complicated. Because theoretically, if you're moving in the air or whatnot, and you hit left, like you should still be moving forward. You shouldn't just like arbitrarily turn left. I feel like the controls for this are require me to sit down and write this out. So maybe I'll do that later today. Three dimensions definitely makes it tougher. But I think the math is fine. So this is just taking the angle based on the input, and I don't necessarily think we want that. I think we want maybe an increment, an angle increment. So if you hit left, you kind of like move left, but not all that much. Trying to think of what should happen to that velocity though. Because in my head, if you start going left, then your forward velocity should move in that direction a little bit more. But maybe that's not true. Because all your momentum is going forward anyway. So moving left and right maybe doesn't even have an impact. I don't know. Maybe I'm thinking of this too early, but I'm thinking of the case where you're moving like 45-degree angle on an incline and you match up with that incline direction and all the normal and the dot product and everything matches up and you get like a good landing. And then where does the velocity go? And I feel like the velocity would go in the direction that you're going, but maybe the velocity doesn't. Maybe it just goes straight. So then we basically have a split of your Z velocity is controlled by whether you've done perfect landings or not. Your X velocity is controlled by like user input. And then your Y velocity is like the component of your Z that launched you off a ramp. So then we basically have a two-directional vector representing velocity that it has sustained momentum, and then one axis that is back and forth. I think that the observer approach to setting linear velocity is kind of hard to think about. And this is the thing that I think I was definitely having trouble with this in the kinematic character controller too. If we use observers from Bevy enhanced input, right, then they execute in the right position in the frame, which is great. And all of the like accumulation and stuff is handled for us, which is great. But the problem is that once you set a linear velocity, there's no observer to unset linear velocity. So I think the only way to do that is to set linear velocity and then have a separate system that like checks whether you had input this frame or not. Which feels really weird. Like, I don't know. Observers feel really nice when they work out, but they kind of work really nice for translational movement. And avian, of course, is physical. So, like, I guess we could just ditch avian for that part. I want to use it for the colliders, though. The thing I still haven't wrapped my head around is it doesn't seem possible to just set linear velocity and have character controller style movement. And maybe I can visualize this. I think it's going to be hard to visualize. Fill the stairs. I don't care about your little math problem. Okay. If we have, for example, stairs, right, and you have a capsule that is lower, like the radius of the sphere part of the capsule is lower than the step, right? Then to get up this step, you have to do a calculation that goes like up and over. So you have to be setting the linear velocity to purely vertical at some point, which feels really weird, right? Whereas if you do transform movement or translational movement or whatever, this can go through that corner and you can check to see if somebody should pop onto the step or the ledge or whatever. But if you're doing like collide and slide on this edge, then you have to go up and then to the right. So it has to like snap around an edge that pushes you out, which feels really weird. Day 3 already. Yeah, so I didn't do day 2. My Sundays are dedicated to This Week in Bevy work. So I spent some time on Sunday catching up on This Week in Bevy stuff. So I didn't do day 2. We don't have any progress since like Saturday after stream, really. So it's day 3, but really it's like hour 5 or 6 for me. So this comes into play when we think about setting velocities. Because if we look at the KCC prototyping, so there was a kinematic character controller prototyping repo that was getting worked on at one point. And if we look into the implementations here, assuming that they are here, this is like all transform based. So it's like right, translation plus equals direction and whatnot. And they've got a custom notion of velocity and a translation that comes in here for move and slide. So it's like, here's your new translation and your new velocity. And that just feels really, I don't know. I'm having trouble reconciling the advice of, for example, the avian creator, John Dolph, who says that this translation shouldn't happen. And that you should be doing everything through like a linear velocity. And reconciling that with the thing that I just talked about for the stairs, which is basically like, if you do everything through linear velocity, then you have to linear velocity your way around all corners, which implies that the user still has to be pushing in the direction they wanted to go. to get around a corner. Have the color secret. Have the character secret, however, one height stair height above the ground. Yeah. I mean, those kinds of things. Sorry, I can. Having a hard time dealing with the smoke lately. So we don't have any stairs. Is something worth saying. What I was just thinking about was the horizontal left and right movement versus the forward movement. And if I'm not supposed to touch transform, then it feels really awkward. But overall, I think that the movement here is just going to be a little bit complicated, and I'm going to have to sit down and really think through it. When I have the brain space to be able to do it, is really what's going to happen. This is just a dynamic body with a forward velocity, and like we could do floating character controller, we could implement Bevy Jam and see what it does. Christ. And the thing that gets me is like everybody else that does kinematic controllers is using like effectively warping, right? So transform modification, which makes, yeah, I don't know. It feels really strange because like if that's the way that everybody is doing it, but we're not supposed to do it that way, then how do you reconcile those two things? Right? In any case, I have to figure out how to do the character movement here. The character movement is like the whole point of the game. I know how to do the landing part of it. I know how to do the like quality of landing detection. If we do kinematic, we have to implement collision for the landscape itself. If we do dynamic, we get the collision with the landscape for free, but it behaves in a kind of way that isn't really what I want. I am curious as to what like the default behavior of Tenua is, but it's so much code to set up Tenua that I don't want to do it. I guess it might have gotten to be less code. Let's see. Tenua controller, Tenua Avian 3D. Apply controls. Apply controls here just uses the Bevy input stuff and then sets the desired velocity and the float height, which are fine. But then if we're doing the desired velocity and float height, how do we do detection for actual collisions? And I think the answer to that is we would need to run a shape cast. which is kind of awkward because then you're floating and you're running a shape cast, and it feels like there could be weird differences there, but maybe not. Anyway, right now all we're doing is setting like a random minimum z velocity. If we do the kinematic, if we're gonna have to do the shape cast anyway, the kinematic requires the shape cast as well. And we need this to be a lot smoother, so I think we have to go either floating or kinematic. I think I'm just going to swap it. We're going to deal with it. And I'm going to ignore the fact that... how do I say this? I'm going to ignore trying to do everything with linear, I guess. So we can detect these collisions. If we use the observer API for both of those things, for like input and collisions, the issue with the input is that we need to directly apply that to the transform. Which I think for our case is fine. So min linear, then we don't really need this at the moment because our linear velocity doesn't degrade if we use a kinematic character controller. Right, like it just keeps continuing. So really we would need gravity to be our first thing here. And gravity... Yada yada, fixed update, min linear, gravity. Min linear doesn't do anything, so we're just going to leave it for the moment. Gravity for velocity and query. This is the same kind of query we need for min linear anyway. Do I want velocity? Not really. This is the other thing. Like, You want to do, if you want to do kinematic character controller, you have to do like kind of snapping to the ground at some point. And like, if you're doing ground snapping, how do you translate that into a linear velocity? Like the whole just feels a little weird in general. Um, okay, so if that's going to be a thing that I need to do later, then what else can we do right now? We can do more landscape generation, but the landscape generation, we need the character moving to do landings. We need the character moving to do like landscape testing. Um, yeah, we have to do movement. Okay, movement is really the next thing. So let's do transform here. I have collide and slide code that I wrote for. Let's see, it's over here. I have collide and slide code that I wrote for a different kinematic controller. So this code will end up being slightly different. But the fundamental idea will probably be the same. We didn't implement snapping, etc. We didn't implement player downward force. Maybe we can just avoid doing a lot of this and do player downward force. If we do player downward force on, yeah, if we do player downward force on static rigid bodies, then it bounces off. That's really the problem there. So if we were going to do that, we would have to do the floating, and even then, I think we would run into that problem. So, do I build a couple of meshes to test things? I think so. I think we can change the noise to a sine wave at the moment. The question is, can we do that inside of the noise crate? I hope so. This is like layered noise, yada, yada, yada. These are all good things normally. Like basically, when you take noise, what you end up doing is like having the contribution or something like that each level. So you do like, I don't know, 4, 6, 8, 12 octaves or iterations of the noise. The root noise is the biggest amplitude. Then it halves and it halves and it halves and it halves. And you combine all of those together and you end up with something a little bit more like a landscape. But right now, I think what I want to do is simplify the landscape to just be a sine wave. So that we can test running off of and down cliffs, which should make the character controller a little bit easier to debug. We'll see how long I can last here because I feel like the smoke is really affecting my ability to think. Land chunk noise. So we use land chunk noise when we start playing. We use land chunk noise when we generate a land chunk. The noise here just gets sampled immediately. So we can change this value to be like what? Vec R2 dot sign. And then we look for our other noise. We're sampling it somewhere else, right? Maybe we're not. Maybe we're just setting it up. There's our sample. So player position then also needs to get the same treatment. And this is always going to be 0. So I think this is always just going to be 0. So we'll just hard code that for the moment. And then this should end up being, oh, this is an F32. So we're just going to make this 0 then. Maybe I drop that at like 0.2 or something. Velocity. Velocity is playing 251. Just comment that out for a second. Well, that's not good. Let's not multiply this by 3. It's the camera. Camera is so many observers. It would be nice if the observers were filtered out by default. This feels like it's just falling at the moment. So let's put the player maybe not at 0. Let's put the player at like 3 to start with. You think your camera is too low. I think the player is out of position. You think the camera is just too low? Like, I'm pretty sure the camera follows the player. Yeah, camera follows player, so player is too low. And then these are all very, very, very like, how do I say this? Let's see, sine is going to be like over 10, maybe. We're just going to extend this sine wave in the z direction. Very high frequency. It's actually just the regular frequency, right? It's like sine, so it's like zeros at every 1, right? Hey Doje, how's it going? That feels weird. What did I do wrong there? Sine wave, but why is it gapping like that from Oh, just broking. Nice. I'm glad you worked stuff out. I think you did work stuff out, right? I saw you in, I think rendering or something, fixing what you were doing. This feels really weird from a. I don't know why our mesh decided to be like completely offset. It should just be a sine wave, unless the sine wave is bugged, which would be really weird. Right? That's a vertical gap at that line. That's really strange. I guess these aren't the right size for the sine wave to finish. Is that correct? That doesn't sound right either. Because the start and the end points should be the same points, so it shouldn't matter. Yeah, there's a lot of weird issues when rendering to a smaller canvas. You have to reposition a lot of things from the original screen space into that canvas's screen space, but you managed to figure it out. Sweet. Glad you managed to figure it out. I feel like the pixelization stuff is something that I feel like a lot of people write implementations for or want, but is not built in. So feels like it's resetting back its value. Yeah, right. I guess this is the position inside of the original mesh, so it would have to coincide with the length for this to be correct. But the position here doesn't coincide with the length. So how do I make it do that? Because we're doing vertex position per mesh. We don't have that many meshes though, is the other thing. So when I hit start here, like we only have 3 meshes, just to be clear. We have 3. So 1, 2, 3, 4, 5, 6, 7, 8. We have like at least 8 kind of waves. You're very new to Bevy, make a new project and everything. When you build run for the first time, the file size got to like 7 gigs of storage. Is that normal? Because it's also not an example project. You're worried about the hard disk space that it's taking up? 7 gigs is not your final binary, if that's what you're concerned about. That's not the final binary size. That's not what you're going to get when you ship to a user. It's not going to be 7 gigs. The 7 gigs you're seeing is almost all incremental compile artifacts. And the trade-off being made there is basically like the Rust compiler wants to do a lot of work to optimize all the crates that you're using. And the place that those artifacts get put so that when you do successive compiles, it's faster. Those will go into the target directory, and those can be fairly big because they have all the debug symbols. They have a whole bunch of other stuff. But you are not shipping that target directory to a user. That is for development purposes, right? And the trade-off there is that the Rust compiler considers for development hard disk space to be fairly cheap compared to other things like CPU time or RAM or something like that. So the debug build itself, or the binary itself, will be smaller, etc. Yeah, so we've got this like what is going on here? This split is happening in the middle of a mesh. Let's cut it down to 1 mesh for the moment. Oh, we have 10. Okay, cool. I don't know when I bumped it up to 10. It used to be 1. If it's 10, that's way more understandable. For some reason, I thought it was 3. And that result for 3 would have been bad. That result for 10, I think, is totally understandable. Yeah. So this is the gap between 2 meshes. And that's because we're not cycling a full sine wave in the length that we have for the chunk size, if that makes sense. So if you have, let's say, 10 vertices on the z-axis, you will end up with, like, I don't know, let's call it like -5 to 5 or something. So if your sine wave has a period of 3, it's going to look weird, right? If your sine wave has a period of 1, you'll get, 5 periods. So basically the issue is this doesn't line up with the chunk size. Easiest way to do that is probably divide it by chunk size. I think we have chunk size set to 50 right now. Yeah, it's 50. We do need to bump this number back up, though. Okay, there we go. That still feels strange. How do I get this to line up? If we have our Z position, is it chunk size over 2 because it's centered? That feels like it's just going to be even more. Why? My brain is not working well today. Basically, each of these is an individual mesh. We have a number of vertices inside of each mesh. Those vertices are, we could like display them out because that's what's coming in here. So if we look at the, like R2 values, and we put a space between these, and then for each of these we do a print line to make sure that it separates. Just trying to save some space in the log that's going to be fairly large. And then we need the dev tools, which I always forget the code for. And then we hit start, and this dumps, hopefully, or not, I guess. Oh, right, because print line won't come out. Ah, okay. Nothing like being forced into info. Info here. I guess we could just dump all the positions. Just feels weird. I could run this natively too. I just don't have the native build spun up. Yeah, if you multiply it by 2 times pi, it'll always be 1 period. Okay, let's do that. Thank you. 2 times pi is the radius of, or not the radius, sorry. Frick, my brain is not working. All right. Let's do over 10 times tau. Or maybe I did that wrong. Um, did we get rid of the infos? I want to get rid of the infos too. Is this really how I find out 2 pi is tau? Okay, so we've got our period happening here. Um, let's try to extend it at least a little bit. No, that doesn't get us a free win. Um, um, why doesn't that work? Because the offsets aren't enough to hold the full period. That's why. Because the way that I have the meshes set up, we're doing the noise for each mesh, which means that the starting to the end position for a Z needs to consume a full period. If the period is longer than the mesh, then we end up not coming back to zero. If the period is shorter than the mesh, then I think it ends up being fine. So if we've got 50, I guess it's 51, isn't it? If the chunk size is 50, where do we have the subdivision? Subdivision is 100. So the plane has 100. That's why that's weird. Divided by the chunk size. The chunk size isn't the same as the number of vertices. So chunk size is 50, which is the length of the mesh. Number of vertices inside of it, it's 100 subdivisions, which I think means 101 vertices, if I'm remembering what happens correctly. So we're using the position. This is the number of vertices. This probably isn't correct. Right? Like, I wouldn't even mind it being exactly one period. So the sine wave is usually per one. So if we have 50, probably divide by 25. My math brain is not working. I'm sure there's a calculator I could be using for this. Tau R2 over chunk size? Tau over, over chunk size. Tau times position. I'm really failing at math right now. I'm even failing at compiling my program now. This is a float. Is that caps? Okay. Y equals sine x. Over 10 is way too much, right? This is the issue we're having. How do you type pi in Desmos? There we go. You think over 101. Yeah, sine repeats every 360 degrees, so that's every tau radians. The issue is I can't work my brain this morning. So if we have a mesh that is 50 units long, then we have like negative 25 to 25, right? And that's the local position for the mesh, which means that this actually needs to be we need to include the offset, right? Oh, no stress, Theo. It's fine. I'm we're stream struggling this morning. Honestly. Just it really do be like that sometimes. There we go. Because we have meshes. Those meshes are 50 long, so it's like negative 25 to 25. We have 101 vertices in them. That doesn't matter. The issue was that we have a mesh and the distances that we're getting inside of the vertex positions are local to the mesh. So we have to add the offset position for the second mesh to those coordinates to be able to pass them into the sine to get the proper sine output. That was the issue. Does that make sense to everybody? Because I definitely took long enough to figure it out. Yeah. Yeah, now we don't have to like try to line up the mesh and like the sine repeat, and yeah, that would have been, I didn't feel right. I just like my brain didn't wasn't connecting. So now we have this. And I think that this is fine for testing purposes. We need to do gravity of some kind. Your game is coming along nicely, so you're just here to scout the competition. Well, hopefully your game is going better than mine. My problem is I picked the game that that directly points at a weak point for me, which is character controllers that interact between like Bevy enhanced input and avian. Like a kinematic character controller in my head makes sense if you can modify the transform. But the thing I'm getting really hung up on For whatever reason. It's just not connecting in my head that we should be using linear velocity for everything. And that doesn't, like, Jesus. Sorry, my neighbors are really, really enjoying smoking outside of my apartment, and it's really fucking bugging me. But why do you want to change the transform? Because to do things like snapping down a ledge, right? For example, we were talking about stairs earlier, because I think stairs are like the egregious case of this. Right. Open image in new tab. So if you're walking down these stairs, right? And you walk off this ledge, what happens? Like if the stair set is small enough, you kind of just want to snap down to the next ledge, right? You don't want to have like an arc where you fall down to the bottom. You want to snap to the next stair as you go down, right? And if you do snapping, that's most easily done via the transform, right? Because you know where you need to be next. And if you use linear velocity, right, but then you're just giving an arbitrary big force downwards, and it like... So the issue then is you come off this edge and you raycast, and now that you're off the ledge, the raycast works. And then you give a big force downward, but it has to be a big force downward to exactly this ledge, which is most easily done by doing a transform, right? If I know where I need to be, then I can set the transform. If I know where I need to be, I can set to transform. If I use the linear velocity, going down is fine, because like I guess you're moving forward, right? And then what the thing is, you change the linear velocity to be straight down, and then the user pushes forward, because it's even worse going up if you have to like jump up these stairs. I don't know. It just feels very... How do I put this? There's no good explanations for it on the internet that I've found. And the people that I talk to that are working with physical systems and stuff like Avian are saying that you should only be using linear velocity to do this. But that doesn't really seem correct to me. So really the thing ringing around in my head is, do I even want a physical character controller? I don't know. I do want like the collisions and stuff to happen, right? So I don't want it to teleport, but... I think giving a force downward and just trying to tweak the value may be easier. Plus, if you made it a resource, you could test it while running the dev GUI. Yeah, I mean, we don't have stairs anyway, so really the issue here is if we are on the ground, which we'll assume that we are for now, even though we technically like modified that. Where's player position? Right. Our sign is this. So this is 0 minus offset, which is 0, over 10, which is 0, a sign, which is 0. So should be all zeros. And we'll put this at like 0.2, so it's just above where we need to be. And I think going up is easier than going down from that thought process. Like I don't want to just add random downward forces. Let's see. Linear velocity. This is a random linear velocity. We have a gravity here. Let's start with gravity. Gravity. Probably shape cast down for gravity. Let's see. If our player is above and we're starting the level, then it needs to know where the ground is to know if it's grounded or not. So we need to have that shape cast anyway. So let's start with the shape cast. Personally, you don't really like avian. It often feels slow to generate a collider and it's always finicky. You'd rather program it yourself with a few mesh raycasts. I think that one of my problems when it comes to this is that I don't have a game development background. My background is other programming stuff. So when it comes to knowing all of the possible approaches for like figuring out how things should collide, I don't have a lot of the background knowledge, and a lot of people like there's not a lot of information on the internet covering all that background knowledge. Let's see, where's our player? Here's our player. We can have this shapecaster. I guess our shapecaster can go a specific distance, and if it's that specific distance, then try to snap to the ground and consider ourselves grounded. So this is our capsule. Vec 3 0 quat default direction neg y. So this will shape cast down. Let's get the physics debug plugin in as well if we don't have it. I don't think this takes a default. Is it physics debug plugin? It is physics. I just misspelled physics. Okay, cool. That is that kind of day, so. Yeah, hopefully this rings true in the videos and stuff that I make, but my background not being in game development means that I didn't build up like all the basics over the last, say, like 10 years or so. So there's our shapecast. I don't know how easy that is to see on stream. There's a lot with the meshes too. Um, could probably even reduce the mesh vertice count, honestly. Seems a little high. Let's see, playing Gen Land chunk. Not chunk size, but subdivisions, we can go down to like 30 or something. Oh, absolutely. You need to dig into books to try to make your own realistic collisions. Difficult to figure out. That's why yours are really very simplified, like in your Moon Rover game. Yeah, one of the things that I was thinking about doing is um, implementing GJK and SAT myself for a video series. Because then not only do I go through the basics of how to do all that kind of stuff, but I also get to document it for other people. So then there's like a video series that handles, you know, like what the common collision algorithms are, how they work, and you know, it probably starts out like doing 2D stuff. But that feels like a very valuable video series. It just means that I need to do like research that is novel to me, which makes the videos harder to make. So at some point that'll happen. The one thing, did we replace this with, yeah, 10. Let's bump this up a little bit more just so that we have a few more meshes to watch this go over. Hopefully 40 isn't gonna be that bad. We did decimate this by about 70 per mesh, 70 squared per mesh. So should be much better in terms of performance or whatnot. You can see a little bit of chunky-ness with 40 meshes. 40 meshes is quite a bit. I think our camera is a little bit too I'm using a smooth nudge as a kind of a hack right now. Your brain wants to go to a Power of 2. We could do a Power of 2. I'm fine with that. Let's see, 2, 4, 6, 8, 16, 32. There we go. Power of 2. Two subdivisions doesn't make a difference for anything that we need to do anyway. We could match the UV texture to the number of vertices we have. That feels like it could be useful. So we have our shape cast. And this will give us the distance to the ground. So if we are close enough to the ground, then we should probably, I want to say we snap to it using a transform, but like realistically, we're supposed to be doing a linear velocity here. So all my programmers love Power of 2. So that's good. We also need one moving forward in the direction that the player is moving. Right now, the player is forced to move straight. I think I'm going to leave it like that for now, and we can do side-to-side movement later. You're not the only one with brain issue. I don't know. I think powers of 2 is like just a nice thing to do in general. Things tend to work out better if you do use them, you know? Like there was an issue fairly recently with MIP maps, for example. And the issue was the MIP maps weren't using exactly powers of two. So I don't know. I feel like generally defaulting to powers of two for stuff is not a bad practice. I think that if you're writing tests, you probably want to test more than that. But in general, powers of two, I think, tend to work out better more often than not. It's just really cool to visualize the shape cast. That's the only reason I'm playing it over and over. Okay, so we've got the shape cast. I think that binary go burr. So this isn't really going to be gravity. This is going to be So let me start with this. Let's do transform shapecaster, right? So here's a velocity, shapecaster, hits maybe is the right, not with max hits. This should be already, nice little car alarm in the background. I don't know if you can hear that on stream, but honestly, I don't think I could program on live stream. Having to talk with people while trying to lock in is not something your chaotic brain can handle. Yeah, I think today is particularly, how do I frame it? Today is a particularly bad day for, like, being productive on stream, I guess. There's a number of reasons for that. One of them being like my neighbors have decided to smoke outside my apartment and it's really, really, really affecting me. There's a car alarm going off right now outside. I don't know if stream can hear that, but it's like, okay, so smoke coming in the window, car alarm going off. Maybe I didn't get enough sleep last night. Like, this is a particularly like a problem domain that I need to really sit down and chew through. Including like producing those videos at some point. All that said, it's mostly fine because like people in general, well, first of all, if they're mean, then they go away forever. I click the button and they disappear into the ether. And the people who are not mean are the people who are left. So it's actually a quite enjoyable experience overall. Sometimes I feel bad, like today is not a particularly productive day. And sometimes I worry about the value of the stream being tied to how much I can get done or how much I can like teach or whatever. But like sometimes I do just need to learn stuff, and learning stuff on stream is more about the process of doing it than the result, if that makes sense. So like me working through this is helpful for somebody. Or people just want to hang out. And both of those things are totally valid and valuable. I don't need to be super uber perfect programmer to be able to, you know, stream or whatever. The car alarm is really... It's just one of those days, you know? You have good streams, you have bad streams, you have good days, you have bad days. It's just how it is. How is it still going? That's a great question. That's a great question. It's restarted like 3 times, I think. Okay. Shapecaster, docs.rs, avian 3D, Shapecaster, enabled shape origin, yada yada. When we query for this, what do we? Oh, we need shape hits. Shape hits is the thing we need. Shepits. Okay, so shape hits. This is what, 4 hit and shape hits, basically? I think for the longer term, we're probably going to need to refactor this code. But for the shorter term, the only thing we have in the scene right now is the ground. So we'll just assume that we're hitting the ground. You probably also always want the first, right? Maybe. I think in most cases. I'm thinking about things like when you are flying through the air. Because we're doing noise generation for the ground, we can differentiate very exactly between something that you are near in the air and the actual ground. And that at some point might be useful, right? If you're in the air and there's like a floating object and you get close enough to it that the is grounded thing would trigger, or the shapecast would trigger normally, but we can tell that you're far enough away from the ground that that would never be true, then maybe we ignore it, right? So if we are going to operate on a hit, yeah, I think for now, yes, always first hit. So do we really need to iter here? No, we can do next, right? And if there's a hit, do something. And this is shape hit data, right? And none is just nothing. We continue or whatever. And this is like info shape hit data, which I don't think works because we need to debug this. Yeah. So this isn't really going to be gravity. I don't think this is going to be our like little shapecast for the ground detection. I think the ground detection probably will do development with it being a little bit longer, and then we'll shorten it quite a bit. Because I think I think in regular gameplay, you're going to have to be very close to the ground to want to register as being on the ground. Right? Like, in the depths of these sine waves, you're almost a full player character above the ground. And that is just not a distance at which, like, it's valid to be considered on the ground. Like, that's just not it. But at the peaks of these, we should definitely be on the ground. And actually, we're interfering, like we're colliding with those peaks. So we should be on the ground somewhere just before the peak, actually, and then be able to go down into the valley. The question here is basically like, if you're running, actually, we probably don't even need gravity. Thinking about the way the character control is going to work, the biggest character input is going to be a fast fall. And this shapecast is really going to be used for like can't get any closer to ground. Right? Christ. I don't know how they're still alive with how much they smoke. So velocity, shapecaster, shape hits. If we are, let's see, shape hits, 0, quad, negative, shapecaster new, max hits, max distance. Hopefully there's a with distance. With max distance. You said it was 0.2 that you said? Yeah. I don't know if 0.2 is the right value for us. I think that the way that I'm going to use this is basically if this is active, then you can't move downward anymore. So I'm just going to negate any negative velocity. So you can see it tapping there. So really the logic we're programming right now is to get over that hump, more or less. Which is also kind of like a forward shapecast. So we can't do multiple shapecasters on a single element, right? Because the type is shapecaster. And there's no... Because we, technically speaking, because we know where the ground is, we actually don't need a shapecast because the noise sample actually would tell us exactly where we were. But I do want to be able to place other things in the level so the shapecast is relevant. The since the collider is rounded, if you go up, the shapecaster should hit on the slope first, so should be fine. Is that true? Yeah, I guess because it shapecasts down, doesn't it? So because the bottom is rounded, yeah, you're right. It will always hit. Interesting. Is that enough to get us up and down slopes? I was really thinking I was going to need to shapecast forward, which I still might need to do for various reasons, but I guess if we're shapecasting and it's hitting and we're getting the normal and the normal isn't... Should I try it out? Yeah, I'm thinking through it. What is the hit that's going on here? So here's our shape hit data, scaffolding. So shape hit data gives us distance, 0.1, normal 1, normal 2. These are the normals for the collision surface and our shape cast. Can we also use this for determining whether you have a perfect landing or not? Since we do have the shape cast. That's interesting. So the question is, if we do this, is the algorithm just collide and slide at that point? No, I don't think it is. Maybe it is. Shape hits. Shape hit data, entity distance, etc. Here's our definitions. The entity of the collider that was hit by the shape, so that's the ground entity. Distance is how far it traveled. If the distance point one, closest point on the shape that was hit expressed in world space. Closest point on the shape that was cast. So we don't really have the transform data here. And we don't get it from shape hits. I guess if the distance is less than some like epsilon, then the hit also needs to be coming from in front of the capsule, right? Because if you're hitting behind, then you would be using the tangent of the downward slope, not the tangent of the downward slope. I'm visualizing vectors in my head right now is what's happening. Because if you're going down a slope and you have the fast fall button pressed, then you are pushing down into the ground, which then becomes like a collide and slide algorithm to be able to push you in the right direction. And I think that that's true as you go down as well. Because if you are all the way down and then you're starting to go back up, then you're still colliding and sliding. I think that's true. I think this is all just the collide and slide. Is the shape cast the right thing to do for that? I don't think so. I think the shape cast that we should be sending is the directional on the player's movement. Yeah, the downward slope's normal. In this case, always face forward, so you could check with the dot product. Yep. Yep. Because dot will be negative in that case and positive in the other case. But this still feels like the downward directional shape cast isn't the one we want to do the collide and slide with. I feel like we want to do the collide and slide with the movement vector, right? Because if So let's say we have a character, it's flying through the air, it's coming down. Maybe you're holding the fast fall button, you're hitting the back end of a slope. That is going to ideally collide at some point with the slope. The ground detection can then be used to determine what the forward vector and the cross of the normal is, and dot product those and determine how similar they are to determine how good your landing was. And then the movement vector of the capsule is going to be the collide and slide vector. And I think that's true generally speaking. And I think that works on the upward hill as well. But that's only in the sine wave case. Yeah, so right now I'm kind of ignoring the case where like this whole track is forward facing, right? But realistically, you should be able to go to the left, right? And if the slope is like 45 degrees to the left and you are going 45 degrees to the left, that is also going to be like a perfect landing. And so on and so forth. So I don't know that it gets more complicated is the phrasing I want to use, but I do think that the movement vector is the one that needs to be used for the actual collide and slide stuff. And then the way the character is right now, it would need to be affected by gravity. So we do need a gravity component to that collide and slide. So like you get gravity, you get player inserted downward force, you get the current movement vector, you add those vectors together, then you do the collide and slide. And that should be the thing that we do, I think. Which is basically this. I already wrote this for a different character controller. So this is not going to be like the right directions and stuff, I don't think. But we can work from it. This is entity collider position transform. Entity collider position transform. I think the transform is what we want to get rid of. And then this will be linear velocity. Right. And desired direction is user input. So that's just the direction we're going at the moment. If you make a component like on ground that holds the normal, you can query for that one and do the slide if you're missing. If it's missing, you add gravity. Oh, yeah, I see what you're saying. I think that I think that's correct. I think we can avoid gravity if we're on the ground. Especially if the player's like holding the fast fall button and they're on the ground. Like we don't want them going into the ground. So really all we're doing at that point is making sure they don't come off the ground. Hey Crods, how's it going? Just an idea so you reuse the shape hit. Yeah, I think that the downward shape cast is going to be useful at some point for detecting whether we are grounded or not, which will impact something at some point, right? I think that's a valuable shape cast to have. I think that the shape cast for the collide and slide, however, is a different shape cast. Right. So spatial query, we get this is our character. I guess this is like with player really, right? And then this is a number of hits and whatever, the origin, the direction, the desired direction is our linear velocity normalized, really, at the moment. Which does feel a little bit weird. I think that's true though. So linear velocity normalized, right? Dot zero dot clone dot normalize dot clone dot normalize. Oh, dir3 from. How do we create dir3s again? You know, sometimes it just don't. It just be like that. Fast free normalize from XYZ, new in length. Do we have a dir3 from dir3, dir3a? Why do I always from dir3 for vec3? From XYZ, new in length, unchecked. I guess we do from XYZ. Why do we not have from vec3? That feels weird, right? Like, I guess try from would be it, right? Like try from vec3. Dir3 new, rave, reflect, normal, unwrap. Try from vec3 for dir3. There we go. Try from. Self new value. That is not a try from. What does new do? New and length. Value map dir. New and length. Vec3. Gets the length. Checks to make sure it's finite and greater than 0. Does the division. Okay, so it's just try from. I feel like it's weird that new does that. But maybe it's not. This is okay. Linear velocity dot 0 because we need it to be a vec3. So we've got our origin, which is our current position, right? Position. We've got our direction, which is our linear velocity as a dir3. We've got slide accumulation and new direction. So these are going to be the like shape hits. Our shape hits are probably going to be. There's no as dir3. Apparently not. That's what I was looking for. But I guess technically speaking, like the try from covers that. So I don't know. I was looking for as dir3, but it doesn't seem to exist. That might just be an oversight, honestly. I think dir3 doesn't exist in glam, right? Like that's not a glam type. Like dir3 is a Bevy type. So as dir3 not existing might just be a combination of orphan rule and or oversight. But yeah, it doesn't exist. But the try from implementation does exist. So we've got our slide accumulation starts at 0. Our new direction starts at 0. Current velocity magnitude, 4 max hits. So in this case, we're doing like up to 5 hits. I don't know that 5 hits is really necessary for what we're doing here. maybe that's useful for other cases, but I don't know that it's useful for the kind of controller that we're building. So we're going to use spatial query, which is a system param that we queried for up here. We're going to cast a shape. So this is doing the same thing as the shape caster, which gives us our first hit, right? Shape hit data. This is excluding itself from the shape cast, so it doesn't collide with itself. Probably that vec of length 0 is not a valid direction and causes that. That vec of length 0. Which vec of length 0? And causes what? Oh, probably that a vec of length 0 is not a valid direction. Yes. We need to do try from because vec of length 0 is not a valid direction. Absolutely. Yes. So there's no, but I think as vec, like as vec 3, for example, these are all fallible, right? No, I guess they're not. Do they panic? No, they don't. So the as vec whatevers are just like from implementations, basically. So it wouldn't be as, it would be to, right? But that doesn't exist either. Right. These conversions, not that anything's going to fail to be a vec 3, but I feel like those, anyway, it's not important. Long story short, there's no as dir 3. I feel like there's conventions around when you use as underscore and when you use to underscore, but I don't think from looking at that either of those are being followed, because Glam is using as vec 3 and constructing a new vec 3, and Bevy is using to vec 3 and constructing a new vec 3. And I think that conventionally, that isn't necessarily what's supposed to happen, but there's nothing restricting any of that either. So yeah. Should just be like, you can give a default if it's invalid or something, but you can, right? You can give a default if it's invalid. Where's our dir, right? Dir 3 new, right? We can do unwrap or default, right? That would work. I don't know what the default dir 3 is, or unwrap or, and then pick a dir 3, right? That would work. I don't know if there's an implementation for default for dir 3. Not derived anyway. Doesn't look like there is a default for dir 3. So you could do unwrap or instead of unwrap or default. I guess no direction is invalid, right? 0, 0, 0 would be invalid because that is not a direction. So you would have to arbitrarily pick something. I don't think I agree with that from the try from, because the try from, right? If we do dir 3 try from, that gives a result. And as the user of that, I can either unwrap that with a dir 3, right? Or I can do any other handling of that. So I think building that into the API doesn't make sense because it returns a result, you actually get the choice to do whatever you want already. So including like a default value into that try from, first of all, the try from trait doesn't have that space for it, right? So try from is actually the try from trait, which has a definition, and that definition needs to apply to anything that you can try from. right? Which not all try froms have default values, right? Like try from is convert try from. This is try from. So you get a value and you attempt to convert it into something and return that value. And if it's successful, you get an okay. And if it's not successful, you get an error. That's the way the trait works. And I think that this is the right way to write this trait. Plus the fact that you actually can handle this result in however you want, right? You can unwrap, you can return, you can do whatever you want, you can ignore it. Gives the user full control over what to do if this fails. So I don't think that a default would need to be like in this trait personally. But I get why you might think that starting out. Like if you didn't know this was a trait, for example, or you've seen this trait for the first time and you're like, why doesn't it take a default value? It's like, well, there's a bunch of APIs for constructing default values or dealing with results or whatever, right? So yeah, like in this case, I'm just continuing, right? Like I don't want to return it. I don't currently have a default value that I want to set. So I'm just continuing with the loop. So our inner loop for max hits does this stuff. Slide accumulation. I think this works for what we're trying to use it for already. So this does transform. Maybe we pull transform back for a second and just see if we can get this to run, and then we'll use linear velocity. This needs to run at some point. I don't know when we're running it. We're probably running it in fixed update in the character controller. That would make the most sense. Or maybe it's prefixed update stuff. It's a great question. Ta-da! So a question here. DevTools. Current velocity is not changing at all. I do want to 339. Is 339 our old cast? No, our 339 is current velocity magnitude, but I want to, 272. 272 is the one I need to get rid of. 272 is the shape hit. Shape hit is the downward shape cast. So I think our current velocity magnitude is generally not changing because we aren't changing it. I know. It's really, really complicated, right? So this moves forward and it's just always that velocity because we aren't doing anything really with that data. I guess we could move the camera too to give it a little bit of a side angle view. That might be useful, but casting here, transform. So we're getting into here and we're logging this and then we're doing a bunch of hits. We are not getting any hits, right? We aren't looping over this at all, are we? No, print is what we're doing there. That's why. Because print doesn't log out. Wow, looking good. Just got back. How you'd fix the issue earlier, if you don't mind. Which issue? Which issue were you referring to? The sine wave issue? The gaps, yes. The gaps, basically, the issue was that we have a bunch of meshes all in a line, right? Like we have, let's say 10 meshes in a row. And the way that I'm doing the noise offsets for the y-axis is we're grabbing the vertex positions for each mesh, which means that those positions are local to each mesh, right? So the issue is that every one of those was going from negative 25 to 25, right? All of them were. And because the sine wave didn't line up exactly with a 50 length period, which we could have done. We could have just lined it up for a 50 length period and then that would have worked. But the real answer is each of those has to be added to the offset on the z-axis, so that instead of getting negative 25 and 0 in the middle and 25, and then 25 and 50 and 75, and then that repeating like negative 25, 0, 25, negative 5, 25, 0, 25 is what we were getting. But what we wanted was negative 25, 0, 25, 50, 75, 100. So we just needed to add the offset for each of the mesh chunks. I don't know if that made sense. That felt really rambly. But basically, like if you have a mesh and you're looking at the vertex positions are local to the center of the mesh. So if you're going to place it somewhere in front and you're going to like have a thing that's continuous over those, then they need to factor in that offset. Yes, that's why it's resetting the values, because the vertex position values are local. They're not global. So if we add the offset, they become world space, effectively. So it does look like we're getting casts there. Question is that whoa? Is that modifying the z-axis? Slide accumulation, right? Hit normal. Makes sense. Thank you. Perfect. Took me longer than I'd like to admit to realize what I was doing there. But it's encoded on the internet forever, so I don't have to admit it. Somebody else can look it up. Okay, so we end up with current velocity magnitude, right? Linear velocity length, time delta seconds. We have linear velocity set at negative 30. We are not currently updating that, so it is what it is, and it doesn't get like maintained. Our casting direction, new direction, Vec 3.0 for new direction. Is that right? I feel like I want a debug camera in here. Can we just rotate it around that point? I don't think so. Not for the way that we're following currently. That's fine. Right, we're not doing any linear velocity modifications here, which is good. So inside of casting, we are getting through 4 loops. And then we are ending up with hopefully a slide accumulation. Really, the thing that I'm looking for is when this hits the like upward slope, it should go up with the slope. I don't think it's doing that. Unless I've specified the wrong size, which is possible. It looks like it might actually be smaller. Where is our capsule size? Radius and half length. Did we make half length 1? So collider capsule 0.5, 0.5, right? Collider capsule, I think this is 0.5, right? And then I think the other thing I want to do is I want to take the player position down a little bit. Just to make it hit the wall a little bit more. Well, they're lined up now, but now we have... These capsules are half lengths, right? Capsule... Collider defined by its radius and its height along the y-axis excluding hemispheres. So this does actually need to be double. Because this is half length for the mesh, but the collider capsule is not. I definitely always get tripped up by that. This site can't be reached. Your JavaScript bundle hasn't bundled. There we go. I think those casts are the wrong size. Let's see. Where's our cast gizmo? First hit gizmo, capsule 3D new, and then this is 1. You feel like since Avian is made for Bevy, the capsule collider should align with the capsule mesh. What do you think? I feel like you're correct, but I also feel like there are multiple ways to... How do I say this? There are multiple ways to generate a capsule, right? So it stores a half length inside of it, but does new take a half length? No, new takes length. Right? So if I were using new, then this would be the same. Right? 0.51, right? So now they're the same. Because the thing it stores in the struct is the half length. But the way that you construct it, depending on the way you construct it, if you construct it directly, you have to specify half length. If you construct it through new, it doesn't take a half length, it takes a full length. This is also something I get like tripped up on constantly, but so let's make this a little bit lower. Player position 0 rather than 0.2. It bothers me a little bit that this isn't actually already working, which makes me think we have a bug, which is constant. That's the constant state of doing anything, right? I feel like once the capsule is actually in the landscape, the visualization is buggy. So we shouldn't take too much from it like warping around like that, because it being inside of the mesh is not a case that we're designing for, right? You should never be inside of this mesh. So I'm not worried about that. I think that I do want to where's our camera? Here's our camera. Let's have another camera. Debug side camera follow. And we'll make this not player follow camera, which is here. But we'll call this a debug camera. And then when we do this, this will be X, Y, Z. Z is going to be 0. I think Y is also going to be 0. And then X is going to be -10 or something. And when we set this up, we'll set it up to actually be pointed at the player. So it'll be like to the side and moving. Where is our systems? Camera follow. Debug side camera follow. So this is the player follow camera. I'm just going to copy this whole thing. And I'm just going to call this debug. And then this, I am definitely like, this should be a configuration that is matched in both places, not something that I have to copy paste, but I'm not terribly worried about it at the moment. So this should give us a like side camera view on this player. That would be a fun effect too. Have it be a 2D like version of it, and then just randomly in the middle, like turn it, and now you're playing from the third person perspective. Like if you chain enough, then you get the benefit of a third person perspective. Okay, that's not going to work. This needs to be more direct. Movement, playing, camera, click, query, player follow, camera debug, smooth nudge. Let's just make this like very high. And then we get our start, and this is our, it's a little awkward, but can we, is there a resource for slowing down time? I don't think so. Time, elapsed, duration. Effective speed, advanced by, last update, overstep. set time step? No, that doesn't sound right. It's like a relative speed. There we go. So we want to set relative speed on, I guess this is what we want to do. Can we just do that to start with? And we're going to set this to like a fifth of the speed and hope this just works out. One of the other things I wanted to implement if I had time was like if you hit something in midair, like a hit stop effect. So manipulating time like this is probably good practice for that. Unless I broke it by doing that. DevTools. Unreachable. Why is this panicking? Who knows? We'll suffer through the native build that I haven't done in a while. Probably should have done that before stream, but you know, that's how it is. So basically what I'm trying to do here is get the get time and slow it down. And time is, if you do res time, you usually get time virtual. That's what all this documentation is saying, effectively. There is a demo. There's more demos. Time set relative speed. So in this case, it's, you know, res mute time virtual. I guess we could set time when we enter as well, right? So we don't need to do what we did here. We could do movement playing, on enter, start playing, and start playing would take this. So we're only going to set time when we enter the playing state, which should hopefully get rid of that panic. That panic didn't have a good error message. I think that working in WASM makes the error messages a little bit harder to read. Or not a little bit harder to read, a lot harder to read. Which is why I was going to build natively. Just curious, is there a reason for you to build it for web instead of doing it for OS X during initial coding? The reason is because this needs to be because this needs to be deployed to the web at the end of the day. If I use OS X native for development, I put myself at risk of doing something or adding a dependency or you know, like using a compute shader or not specifying the padding for a WebGL struct in one of my regular shaders or something like that. I open myself up to a lot of things that could go wrong, but will only go wrong if you build for web. That's why I'm doing web development first. I personally don't typically build web Bevy stuff, right? The Bevy apps that I usually build are mostly native. So I usually do all of my work on native. The Game Jam basically requires a web deployment. So making sure that I'm not messing up that web deployment. And if I do mess up the web deployment, that I am cognizant of it at the time that it happens makes it much easier to fix, right? If I do something and it breaks the web build immediately, I go, oh, the last thing I did broke the web build, which is, I feel like something that, like especially newer engineers don't value very highly. But for me, it is, I will go through a ton of pain just to know that when I made that change specifically, it caused the error. I like the idea of doing a bunch of native development, for example, and then having an error after I've done a bunch of feature work and then needing to figure out which feature it was. That is much harder. It's not impossible, right? But like you waste a lot more time doing that. And I think I would rather spend the time trade-off in the iteration process rather than like walking myself into a corner. Yeah. Yeah, I know you get it, but I like I'm explaining it more for like stream and the recording, you know. So the slowdown here, I feel like needs to be even a little bit more. The chunking that we're seeing here is related to like fixed time step and not doing interpolation on, say, like the camera and stuff. So I'm not actually worried about the chunking. The chunking is like this chunking specifically is not going to be a problem long term. That is an easily fixable thing, especially with especially with the way this camera that we're using right now is only meant for like debug purposes, more or less. This is actually visualizing every fixed physics time step without interpolation is what's happening here. Maybe it's too slow. Who knows? Maybe I should be recording this so that I can actually replay it at my own speed. But basically what I'm doing here is I'm slowing down time such that I can hopefully see a little bit more of what's happening. I don't even see the collision happening there. The only collisions I see happening are when we're already in the wall, which is weird. Let me... What's the answer to that? We're currently using the linear velocity as the direction. The max hits is 5. What if we bump this up? It does need to hit something to visualize. We could also like greatly expand the linear velocity. The systems ordering is wrong? Why do you think the systems ordering is wrong? You're talking about this chunkiness? Is that what you're... I guess, what do you mean by the systems ordering is wrong? What we're seeing here is actually the difference in... how do I frame this? This is the effect of a fixed physics time tick with a linear velocity at slow motion, right? This is actually what's happening, right? It is moving forward like this. This makes sense. Oh no, the debug drawing of the capsule happens immediately. It being behind is, I think, an indication of a bug more than anything. Unless you mean like you think this is correct, which it could be. Is this correct? We do get the normal correctly for the position that it is. I think you're right, actually. And then the white arrow is the direction that we should be moving in. I mean, this just happened to stop at a perfect frame. I actually can't tell you why this stopped, honestly. It might literally just be taking too long to do the dev tools. We panicked at, the length is 6, but the index is 6. 409. Oh, yeah. We panicked at visualizing it. That's funny. Got an implicit stoppage at the first instant that we drew the gizmo because we panicked. That's funny. So given the collider, assuming the collider is 1 frame behind, right? This is not actually, how do I frame this? Oh no, you broke time? Yes. Well, we panicked is what happened. We panicked because the list of colors that I have for doing the visualization for the ray casting is a array of length 6. And I made it have 25 steps, which means that on step 7 it panics. Which is fine. We can fix that. That's easy. I'm taking this opportunity to look at and evaluate the actual raycast here, or the shapecast. So the red visualization is the visualization of the shapecast itself. And I think that the calculations are all correct, right? I think that that white arrow is actually the direction we need to be going in. So I'm actually not sure this is even wrong. Which brings up kind of an interesting question, I guess. Slide accumulation delta seconds times 3. That feels weird, right? Times 3 looks arbitrary to me. Yes, probably would be better with an orthographic projection. Projection. No scaling mode, not 2D. We'll just go with the defaults. So projection orthographic wraps either orthographic or perspective projection. The orthographic projection got two new default functions, one for 2D, one for 3D, which is actually really important because a bunch of people were tripping over the fact that the 2D defaults for the projections were changing the far and near plane clips. We do need to figure out what the right kind of zoom here is. Orthographics, scaling mode, window size. Honestly, this is actually sick to not see the meshes and only see the gizmos. Not really what I intended to do, but it is sweet because now we can see what's going on here. You know what I should implement? Time stepping, but or system stepping. That would be fun because then we could see this go back and forth. As long as it's in the ground, it's wrong. So it'll get out at some point here. So that's when our ground detection stops. And then we wait forever because I decided to go with a very slow time step. It's funny that our camera movement is super smooth. Okay, so we're about to see the projection here. And I don't think it'll register until it hits, which seems too late. But that does seem like the right direction. So really the question is, why is it... times 3 was it, right? I feel like the times 3 here is really weird. I don't want it to be the translation. I do want to change the linear velocity. Because otherwise we still get the same linear velocity. The slide accumulation is something that we need to bring up and check. So slide accumulation here. Oh, right. I didn't change the scale factor. So we end up with slide accumulation being 0, 0, negative 0.4. And I think that's because it never changes. Once it's inside, we get a slide accumulation of 0. But really, because we aren't doing a velocity change here, I think we don't get what we want. So the question is, slide accumulation is tiny, right? Slide accumulation is apparently not want to show itself. 0.46. So really the question there is, I guess what is the velocity that gets us there is the thing. So we just add this to our velocity. Is that going to work? That feels really weird. Yes, the double D reference. Oh, not borrowed as mutable. Mute. Not borrowed as mutable and not borrowed as mutable and it's a shared reference. Why is it a shared reference? Because we're iterating over it? No, mute linear velocity because I didn't make it mute in the query. That'll do it. Get rid of the logs, refresh the page. Whenever the server kicks back up. Really should change this projection in the actual number, but okay, so the slide accumulation is slightly changing here. It is just increasing or decreasing depending on your viewpoint. So really the question is, at that point, did it go up? We'll record, projection, camera. Slide accumulation is only going up. That's because the velocity for our Z is only going up. So we're going faster and faster. I think it did work just then. I think it worked for exactly one step. Let me open this in the trim just to get a better look at it. So if we cut this all the way down to the point at which we need it. Okay, here's right before. There's one. That goes up. And then it goes in. And once it goes in, we're screwed. Right? Unless I'm wrong. That went straight. I think it's just going straight. It's not going up. Not going up at all. So we aren't getting any vertical here. That's got to be due to the algorithm that we're using for determining these vectors. But the white vector is correct. Right? That's the right direction. So if the white vector is correct, that means which one of these is that arrow? That arrow is this arrow. Position plus slide accumulation is where we need to go. So really what we should do is modify the direction of the current velocity to be the slide accumulation direction. Does that sound right? I think that sounds right. So to do that, we can do the slide accumulation dir, right? Let's do this all the way down here. Let slide dir equal dir3 from this, else continue. We're just going to ignore the error for now. I guess info invalid slide dir. So dir3 slide accumulation gives us a dir3 here, right? And this is okay. So we have a direction and we need to translate our current velocity vector into that direction. Right? That is how that works. So we could take the magnitude and multiply it by the direction. Right? So linear velocity equals linear velocity dot length times slide dir. And none of this is happy with me. Let's get rid of, let me save this. Just trim only, save, replace video. Save. Just so that I have that for when I need to make the devlog for how I messed up my kinematic character controller for dir3 try from. So it's dir3 new is really what it is. You know what I should do though, before I do this yet again. Where's our camera? Camera's here. Orthographic projection. Near, far, scaling mode, scale, area. I think we're just doing scale, right? 0.01. Come on. Dot, dot, no comma. Fighting my syntax at this point. The window size is the default, so we don't need to set that. But that is correct. Okay, so slide accumulation is still running at negative 0.468. So we're maintaining our current velocity, is what that tells me. Do we do the recording again? Hit the record button. So this gets close. And it goes up. It's going up. We've done it. Oh, what a day. What a day. OBS Studio disconnected. Perfect. What a day. Right when we get it. It says OBS reconnected. Hopefully that's still streamed out. I'm just going to save this. Okay, so that works. And then we fly off, which is intentional. That's intentional for sure. Let's get our time back so that we're not running ridiculous time. And let's not do our orthographic. Let's do our regular. I'll probably throw this behind a flag just so that I can like enable, disable that camera whenever I want to. Or maybe it won't be a flag. Maybe I don't know. Maybe I'll do something else for it. But that view seems very useful, even if the only thing I use it for is like a visualization in a video at a future date. Okay, so this should be regular speed. And what should happen is our thing should hit the first hill and take off and go to space. Because we don't have any gravity, remember. So we aren't getting any like downward force. And we don't have any user input for that yet. There we go. That's it. That's what we should see. That is perfect. And by perfect, I mean it works. Let me just take a clip of that. CleanShot is really nice. I do have to say, CleanShot is one of the pieces of software that, as somebody who makes videos and stuff and shares a lot of images, CleanShot has made my life nice. I do like it quite a bit. Okay, so we've done that, and then theoretically, we should have gravity, and gravity should apply if we are not grounded. So apply gravity. Don't apply gravity. Right? So here, velocity dot y minus equals, or maybe force. Is force correct? I don't think force applies to kinematic, does it? So I think we need to handle this ourselves. So velocity dot y is what? If our gravity is going to be some acceleration, like 9.8, which is probably not, you think gravity times time is enough? We can go with that. I think you're right. Minus equal gravity times time dot delta. Time, res time. Velocity time dot zero dot y. What did I do here? This is not velocity. This is transform. That's why. Linear velocity is what we need. Linear velocity, shapecaster, shape hits. If we are not in contact with the ground, is what this is saying, then we need to do vec3 new minus, yes. So we're going to do zeros here. Just making sure I don't. Minus equals y. This is probably going to be the dereference issue that I thought I was going to have earlier, but didn't. What do we have? We have no implementation for F32 minus equals prelude vec3. Right. Uh, why did that not work earlier? Right. Okay. I don't know. I didn't have what I thought I wrote earlier. Considering a Euler integration, sorry. Other integration methods are available. Midpoint Euler, Verlet, with simple Euler is the simplest. Yeah, maybe if I can get all this done, maybe I'll go take a look at like a velocity Verlet. Um, I that's the other thing. I feel like the integrations that I see described. So there's one really good video, Rungakata. Yeah, there's a really good video. GDC building a better jump. And they talk about literally everything that you just mentioned. Math for game programmers building a better jump. Highly suggest this video. Talks about Rungakata, talks about velocity Verlet, talks about all those things in the context of how do you design a jump and what inputs do you use to make that jump a reality, which I really like because the way they frame the problem is like, you should have like artistic control over the things that you care about and then use the math to implement that. But this video is something that, yeah, I would definitely, absolutely suggest watching. And I think I'm also going to. Oh, look at that gravity. Look at that gravity. Okay. It was a rough stream. Oh, and we've got a bug, but that's fine. We're going to ignore the bug for the moment. Is the bug that, yeah. Perfect timing, looks great. I mean, we fall through pretty consistently on, I think, the fourth jump. I think if we land on the upward slope, I think is what happens. If we land on the upward slope, then we have an issue. And that's something I can debug. But this is like absolutely like the gameplay loop. Basically do this. Hopefully you don't fall through the floor. I need to fix that bug. And then if you can land on the downward angle or the downward slope of these hills, then you get a speed boost. And then the idea is the more perfect you land on the downward slopes, the more you can line up your vector with the vector of the slope that you're landing on, the faster you accelerate, and thus chain reaction, thus the game jam theme. And then hopefully I can get around to putting in some like rings and stuff. I've had a ton of ideas. Everything from, hey, this could be like a little skateboarder and you could put rails on it, all the way through to, hey, this feels a little bit like Sonic. To like, hey, maybe this could be like SSX tricky and you're doing like snowboard tricks in the air. Could be any number of thematic applications for this, I think. Really, it's just going to be picking one and scoping down because I'm not going to have time to do like, I want to be able to spend like a full day on art and a full day on like audio or something. So we're talking about having ideally gameplay and the game loop done within the next 48 hours. I'm generally happy with the... Oh, this one made it further this time. Why did it make it further? Anyway, there's a bug there that I need to figure out. That might even be related to the fact that the meshes here are not solid. So it might be as easy as changing the colliders for the meshes to be like convex holes or something. This may be just like, oh, you slipped through what is effectively a very thin collider. Definitely reproducible though. So definitely something that I need to fix. What time is it? 11:20. Cool. Let me hit the record button and let this run. That's cool though. It was a bit of a struggle of a stream, but you know, I'm very happy with that result. Maybe put the shape cast up a little bit so you never miss a hit. Put the shape cast up a little bit so you never miss a hit. You mean like up on the y-axis compared to the collider? I feel like it would have to be down, wouldn't it? If the shape cast is up, then the collider will hit, or the collider will pass through actually before the shape cast, right? That's an open question to what is actually going wrong, actually. So let's take a look at, let's just take a look at it. We have our camera. We can just replace our player camera with our debug camera. We can watch. You can reload this page when it reloads. Unless I crashed it. No, I didn't crash it. It's just not loading. Come on, Chrome. You can do it. That's so cool. That, whatever that was. So let's get a recording going. Let's just start it. Maybe we can just see this by scrubbing frames. Your guess. Player hit a flat bottom, does not go up. Next frame is below ground. So that's a very good guess. That does seem to be pretty accurate for what's happening there. Right? It hits here. So we're shape casting, it's going forward. It doesn't hit anything that frame. Doesn't hit anything. Doesn't hit anything. And just starts falling through. Yes, that's what you mean. That's fair too. Are you behind a little bit on stream? So do we not deal with straight ahead shape casts well? Is that the issue? Is the issue that we are our shape casting is effectively not going far enough forward? Got more alarms. Right? Because here, this looks good. The visualization is go forward. I don't know how to do a single frame forward, so I'm just gonna, there we go. And we are going up a little there, up a little there. I think we're in. That ground cast looks weird. Ground cast no longer hits in the center. So we are in the ground there at that point. Continuous collision detection would solve this, but might be a bit overkill. You think that's what that is? Let's see. What do we got here? We've got... there is CCD. Probably something worth considering the fact that we're trying to get this to move faster, right? We're trying to get the player to accelerate. So if we're trying to get the player to accelerate, continuous collision detection makes a lot of sense if that fixes collision problems like that for us. Because ideally, you're going faster than the body currently is. You're going much faster, right? So ideally, yes. And then CCD would only be used on the character, so I don't think we need to really care about the expensiveness of it. So really the question is, swept CCD default, that's on a dynamic body. These are all dynamic and static. So we might have to look at the code to figure out what it's actually doing and then take that into account. I feel like generally Collide and Slide should be handling this for us, right? Like we are doing the whole process here of casting forward, figuring out if there's a hit, and then modifying, right? Modifying our velocity. So the question then is, is it just a max hits issue? No, because if it was max hits, it would be showing a hit. The max distance is the current velocity magnitude. I think that's correct. Except for the fact that those values tend to be very small. Just out of curiosity, let's multiply that. This may just send us off into space, but at least it'll be interesting. I mean, that solves the problem. It solves the problem basically by not letting us get close enough to that position, though. But if you hit and slide the flat ground right before it goes up, it'll go through, and the next hit in the slide will miss the collision, which continuous could probably solve. Also, collision restitution bouncing might solve this, or at least make it less frequent. You mean like bouncing off the collider? Yeah, I'll have to look into what the answers are here. Because I don't actually know. Obviously, we're tunneling into the ground, and that messes everything up. So we have to prevent ourselves from going into the ground. To do that, our cast has to be longer than the distance that we're going to go. right? So even just multiplying it by 2 fixes the problem entirely, it seems like. Right? And I think that's really all it is. I think the cast just needs to be the cast needs to go further than the character is going to go in the frame. And I don't know. The easiest way to do that is obviously to like double the cast or like add something to the cast distance, right? But I don't know if this is like the right answer, if that makes sense, right? Like this is like it works. And maybe like basing it on the velocity is good, right? Because velocity, even if it's like something maybe smaller, like 1.1, could fix this. But it feels a little bit like a hack. And I don't know if this is like, I don't know if this is effectively like the skin width that we should be calculating, and I'm not taking into account the skin width of the collider, and thus that's the issue. Because that feels very similar, right? Like if we're saying that the cast needs to go a little bit further, then the amount that we're going into this, like even 1.1 works. If it grows by more than 1.1 in a frame, it'll break again, you think? Is there an easy way to test that? Also, the velocity shouldn't be growing. We're doing no velocity acceleration, right? Where's our dev tools? Right? We're only logging out the slide accumulation. I guess Z is very slightly increasing. Point 0.55, 0.56, 0.57, 0.58, 0.59, 0.6. So there is an accumulation happening. We are moving faster. Shouldn't it, if you wanted to press down, you wanted to speed up, right? Yes, but I was expecting to have to add to that speed. I was not expecting it, because right now, just to be clear, I'm not pressing the keyboard. This is the effect of a purely horizontal velocity plus gravity plus the collide and slide. That's all that's happening here. I'm not pressing any keys. I'm not accelerating this at all. So the fact that this is accelerating, I guess, means that it's landing on... I don't know. It doesn't feel right that it's accelerating currently. I don't feel like it should be. And I think that that might be directly related to the scaling that we just did here, right? It's hard. It's going to be hard to tell because this will crash, right? But right, because gravity is getting added to the velocity. So if it lands with gravity, we don't take anything out of it to counteract gravity. So gravity is actually always accelerating because we don't have any dampening on the horizontal velocity. So the gravity is always adding to that magnitude vector. So that's where it's coming from. I think you're right. Yeah. So it's not related to scaling because it's still going up. So it's 0.49, 0.5, and then we're through, which is, whatever. But it is accelerating before that happens. And that does have to be gravity, right? What just happened there? Yeah, magnitude is 0.49, 0.5, 0.51, 0.53, 0.56, and then it just keeps going up because it's falling. So I don't know. I'll have to figure it out. I'll have to think about what I want gravity to do here. Not always adding, subtracting when landing on an upslope. Yeah. Yeah, taking into account so that's one of the things that is going to be a next step. Because if you do a perfect landing, right? If you land on the slope and you land perfectly, you should get an artificial acceleration, right? That's part of the chain reaction part of it. If you land on flat ground, basically, I guess nothing should happen. Well, not if you land on flat ground. If you land on something that is non-perfect, so if you're not parallel to the surface at which you're landing, right, then you should not get that boost. If you land on something that is actively against where you're landing, something that is more like the best example would be like a wall, but more like the upslope of a hill, we should get a reduction. So yeah, it is very much like the haste game. It's also like there's another one, Tiny Wings is another variation of it that was older. If this will load. Tiny Wings is a 2D version of it, but this was a Flash game staple. Tiny Wings was the iOS version, if I remember correctly. But there were alternatives too, right? Like this is when you go down, you accelerate, you launch off, you accelerate, you launch. And this is kind of just physical, I guess. And then if I hit this wall, then I stop, right? But this is the general idea. I don't really want to do this specifically. I'm just watching how the bounces are happening. It's got a minimum velocity for sure because I'm not clicking anything right now and it's always going forward. So you never actually stop until you hit some point at which it's day is over. But that wasn't related to speed at all, I don't think. But yeah, it's like a Flash game, old Flash game concept. Seemed, and I did play Haste recently too. Haste is very cool. I do like Haste. Haste is 3D version of that. I I actually recorded all of my haste play because, oh man, I hate cookie things. Is this gonna play well? Cool. So obviously going to be better than what I'm going to make for the game jam. But there's a very similar concept here, where you land on, the downsides. There are some other stuff. There's items and whatever. Yeah. What if for now you just add, if you're holding a button down, give it a downward velocity to try and find out if it works with just physics? Pretty sure it would work with just physics, right? Okay, so we need Bevy enhanced input, right? We've got enough time to do this. So Bevy enhanced input. Let's do, where's our setup? Movement. Here's movement, linear velocity. We need a button for down. Input context, grounded. This isn't really grounded. Shrug. Move. We need to have fast fall, I guess we'll call it. Right? And this basically is just going to be a multiplier on gravity more than anything else. Input action. Output equals F32, I think. I guess you don't really get much of an option for like whether this is active or not. How do we handle Bevy enhanced input? It's got to be an example of a key press, right? Yeah, output equals bool, jump. Jump is basically what we're going to do. Basically the same thing. Jump. Input conditions. This is if you've held it for 1 second. I don't think we need any input conditions currently. So we'll just put this in here. This is fast fall. Space, why not? Shift is your go-to. I can't hold shift like that. The shift for Minecraft I have on like caps lock or something like that, if I remember. No, actually, now that I think about it, I have a Moonlander, so the crouch button for me is actually my thumb because I have triple thumb buttons. So this top left thumb button towards the keyboard, like towards the V or whatever, this horizontal one, that's my crouch. Because I hold it all the time. And I don't want to hold like my pinky like curved under on shift. That doesn't work for me. So the question then is, not apply movement, but gravity. Gravity plus equals jerk times time, also considering an Euler integration. Minimizing jerk is the objective in engineering, otherwise whiplash or mechanical damage. Or low score. Where are we? Gravity's here. This is what we have for that. Actions. This is not, grounded is the wrong thing at this point if we're doing it like this, because we're going to be fast falling from the air, but that's fine. I'm going to fix up the input later. So pub fast fall and pub grounded. And this is fast fall. And we need both of these from movement. Import fast fall. So this is what we need here, right? We'll throw this in actions grounded on player. $50-50 on this question mark, but shape hits, this is actions. Match shape hits. If we're applying gravity and we have fast fall, then we do one thing, else we do the other. The other is just going to be regular gravity. This one is going to be gravity times 2 for kicks. This doesn't return in that sense, so this needs to be I don't know what this returns. I'm just playing with values right now. This is a result. Binary operation cannot be applied to result. Dot is okay and fired. There we go. Option grounded? No, not option grounded. Your point. Jerk is a more understandable term than fast. Oh, that's what you meant. Got you. Jesus. I'm going to leave that for later. I'm going to leave the comment for jerk. What was the thing you said? You said gravity equals jerk times time. Christ, I can taste cigarettes. 9.8 times 2. So we just increasing the effect of gravity here. We aren't doing any detection for whether we're actually grounded or not. That can come later. Plus equals. Kind of half half typing, half doing. So that should be good then. The question is, did I add this to the player when we spawned the player? Player, mesh, transform, shape collider. We don't have anything on the player. We probably need to put the actions on the player, right? Do we not need to do that? Player get mute trigger, trigger transform, trigger fired move. I guess it's not on player, is it? Completely disconnected. I think I was thinking it was on player because Leafwing has it on player. Find actions. So action events then is not a component. Right? Like actions grounded there won't do it, right? Why does this... Did I just miss this? Am I just like staring at this and missing it? Actions bind actions. Jump, reacting, pull. Is it just not here? Project Harmonia, Bevy Enhanced, Flycam. The last code block. Troubleshooting. The pull style code block. I mean, I get that they're querying for this here, but they don't show actually inserting this onto the player. Right? Like there's no... This is actions on foot, mute transform, which has, like, actions on foot has to be on player, right? Right. I'm not looking for the query though. I'm looking for the insertion. I'm looking for this. Actions grounded needs to be on player. Right? This needs to happen. Yeah, not on that page. Yeah, that's what I was saying. So, theoretically, this would work, assuming that everything's set up correctly, which I didn't check at all. Well, I can send it through the floor. I'm just holding it down right now. Let's see if he can play his own game. That's always the difficult part, isn't it? I'm not supposed to be able to play it. I'm just making it. So it goes about that high when I'm not holding. 1, 2. Yeah. So, I mean, it definitely is... I don't know why that happens. That was really weird. Like the dev tools randomly closing. That doesn't make any sense. Anyway, I think that that is a good place to stop for today. We're reaching the end of stream. We did get the vast majority of this to work. That was really weird. I don't know what that was. That was a bug. This is a bug. The way it's falling through needs to get fixed. That doesn't have any relation to the groundedness or whatever. You think now the velocity grows over 1.1? We can actually check what that effect is, right? because the gravity we could do like times 7 or something. I can bounce it off the ground. That's probably too much velocity or too much gravity. I mean, that looks like it's accelerating. Dev tools, open, clear. Yeah, I can definitely get it to accelerate a little bit more. That's not really what I want in terms of like player behavior, I guess. Like I want the it works to an extent, but I would like to have a more designed experience for that. My next step is going to be to figure out how to fix that falling through the level issue. And once I have that, then I can start doing vector like dot product detection for how well you're landing. And then from there, it's just kind of like how much can I build before we have to submit. But that's it for today. Thanks everyone for hanging out. Tomorrow's Tuesday. I might stream again tomorrow. We'll see. I'll put it up on the channel as a scheduled stream before the end of the day if I am going to stream. So have a good one, y'all. Thanks for hanging out.